Chapter 12, Section 5. Circles in a coordinate plane. It's a pretty straightforward section. It's only one theorem. It shouldn't take too long. So we have a circle. This is theorem 16. We have a circle. It has the center of the circle with the coordinates of h and k. And then we have the edge of the circle with the coordinates x and y. And then we have the radius. And it has a particular equation. And the equation is this: x minus h squared plus y minus k squared is equal to r squared, or r is the radius squared. Remember, h and k are the coordinates of the circle. H is the x coordinate, k is the y coordinate, and then x and y is the coordinates for the edge of the circle. So you're always going to subtract x minus h, never h minus x. You're always going to subtract y minus k, not k minus y, because it's always going to be the distance from the edge of the circle to the center of the circle, and we're going to square it. Everything's going to be squared. The reason why it works is because it's essentially the distance formula. We learned about the distance formula earlier. Instead of distance, it's the radius. Instead of x2 and x1 squared, it's x and h. Instead of y2 and y1 squared, it's y and k. Notice that the last part of this section here, where it says why it works, it squares everything, right? R squared, squared, and squared. This is called the standard equation of the circle. So everything is essentially squared. So for number 1, for the got it, they want you to write the standard equation of the circle. So we know that the equation is r squared is equal to, actually most people write it like this, x minus h squared plus y minus k squared is equal to r squared. Now we have the center is 3 and 5, so that means that h is equal to 3, k is equal to 5, and then we have a radius of 6. So when we write this equation out, we're going to substitute the 3 in h, we're going to substitute the 5 in k, we're going to substitute the 6 with r, or r with 6. So it's going to be x minus 3 squared plus y minus 5 squared equals 6 squared. And then we square the 6, so then our last form of this equation is going to be x minus 3 squared plus y minus 5 squared equals 36. This is the final form of this equation. So you substitute it and you square the radius. For number 2, or B, they have a different scenario, and that scenario is that the center is -2 and -1, and that the radius is the square root of 2. So here's the difference. So our h is -2, our k is -1, and our radius is the square root of 2. So when we do this, it's going to be x minus -2 squared plus y minus -1 squared equals the square root of 2, and that's also squared. So when we square all of these, and remember this part right here, when we have a negative negative, it's a double negative. So a minus minus a negative is the same thing as saying plus. So when we write this out, it's going to be x plus y plus 1 squared. And remember also that the square root that's being squared, these guys cancel each other out. The square root symbol, the radical symbol, and the square cancel each other out, and you're just left with whatever in the middle. So square root of 2 squared gives me 2. And that would be the equation of this circle. X plus 2 squared, or the sum of x and 2 squared plus the sum of y and 1 squared is equal to 2. Points on a circle. So they say, what is the standard equation with the center 4, 3 that passes through the point of -1, 1. So when it says it's passing through the point is the center of your circle because it's a point. And then it says the 4, 3 is passing through. So this is a two-step problem. The first step is to find the radius or the distance using the distance formula, and then after that, then you can set up your equation. So step 1, they give us that x and y is 4 and 3. I don't know why I did that. They give us that h and k are -1 and 1. So then we use the distance formula, and the distance formula is x minus h plus y minus k squared, and that whole thing is square rooted. So we're going to do some substituting. So the distance, remember the distance is also your radius. So it's going to be 4 minus -1 squared plus 3 minus 1 squared. So that's going to be 4 plus 1, which is 5 squared, plus 3 minus 1, which is 2 squared, which is 25 plus 4, which equals 29. But remember, this whole thing is being square rooted, so we have to also square root the 29. So our distance, which is our radius, is equal to the square root of 29. So we have our radius. Our radius is equal to the square root of 29. And once we find our radius, then we can use the equation of a circle, which says that radius squared is equal to x minus h squared plus y minus k squared. So this is going to be the square root of 29, and that's going to be squared, is equal to 4 minus, x minus negative 1 squared plus y minus 1 squared. So that's going to be, the square and the square root cancel out, so it's going to be 29 is equal to x plus 1 squared plus y minus 1 squared. And that is our equation. So that's got it, number 2. And then number 3 deals with graphing. For number 3, and we're not going to do any graphing in this. So that is our section. It's really quick. It's just that one equation and variations thereof. They have a couple problems here, 1 through 4. I think would probably be worthwhile to do. So let's give it a go. So for lesson check number 1, they want us to write the standard equation of the circle. So they give us a center of 0, and they give us a radius of 4. So remember that the equation of a circle is going to be x minus h squared plus y minus k squared is equal to the radius squared. So we have the center, so h equals to 0, k is equal to 0, and the radius is 4. So when we write this equation out, it's going to be x minus 0 squared plus y minus 0 squared equals 4 squared. Well, x minus 0 is just x, so that's going to be x squared. Y minus 0 is y, so it's going to be y squared. And then 4 squared is 16. So our equation of this circle would be x squared plus y squared equals 16. So that's number 1. Number 2, they give us a center of negative 1, or 1 and negative 1, and a radius of root 5. So h is equal to 1, k is equal to negative 1, and then the radius is root 5. So when we do that, it's going to be x minus 1 squared plus y minus negative 1 squared equals the square root of 5, and then that's also being squared. So then this is going to be finally x minus 1 squared plus y plus 1 squared, and the square root of f and square cancel out, and equals 5. that is the equation for number 2. For number 3 and 4, they want to know the radius and the center of each circle. 3 and 4. So for number 3, they give us the equation x minus 8 squared plus y squared equals 9. So if we look at our standard form of the equation, the 8 refers to the h, so I know that h equals 8. If we look over here, there is no y minus k, right? But I know that I can say y minus 0 squared is the same thing as y squared. So since I know that it's y minus 0 is the same thing as y squared, I can say that k has to be 0. I have this 9 here, but remember it's radius squared, so it's really 3 squared, where the radius would be that 3. So my radius would be 3. So if I was going to write down this coordinate, it would be that the center coordinate would be 8, 0, and then my radius would be 3. For number 4, I have that it is x plus 2 squared plus y minus 4 squared equals 7. So I can rename this a little bit. X minus negative 2 squared plus y minus 4 squared equals 7. So I know that my h is negative 2, my y is 4, and again remember this radius is, this 7 is squared, right? So radius squared equals 7. Then I would just square root both sides, so then my radius would be square root 7. So in this case my radius is the square root of 7. When I write the coordinates out, it would be negative 2, 4 would be my center, and then my radius would be the square root of 7. This would be my answer right here. Okay, and that is section 12.5. Hope you have a great rest of your day.